All right, question number 4. We want to write each set as indicated on the form. We're going to use set builder notation and roster form. All right, so the first one wants us to use set builder notation, and we have x is an integer, and 3 is less than x, which is less than 6. So first, let's talk about the number groups. I'm going to draw all of them. It might take a little bit of time, but this is going to be good, and you'll use this throughout the course. So this box is going to represent all of the real numbers. Okay, real numbers is also denoted with this like boldface R. Every number that you can think of is a real number. We're going to split the real number into two groups. Now, it's not going to be in half. One group is much larger than the other, but these two groups are going to be rational numbers and then irrational numbers. Now, there is a symbol that denotes rational numbers. Since we've already used R for real, they use Q for like a quotient. Okay. Rational numbers are numbers that can be put in a fraction form. All right. That's the basic idea. I'm just going to say fraction. Now, there are 4 different numbers that will fall into this category. You can use whole numbers, negative or positive. If you put a whole number over 1, you get a fraction. Fractions, of course, are in this group. Decimals, most fractions can be converted into a decimal. So if you have a decimal number that stops, it has a countable number of places, 1, 3, 6, for example. That can be converted into a fraction. Whether you know how to or not, it can. And then you also have non-ending repeating decimals. So let's just say like 0.333 repeating. Okay, so you can do a box, or sorry, horizontal line, or you can do a dot, 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 which is called an ellipse. But any one of these numbers can be converted into a fraction. So a rational number, something that can be put in a fraction, that includes whole numbers, fractions, of course, decimals that terminate, and decimals that go on forever, but they have to repeat. All right. There is a group of irrational numbers. There's no special signal or symbol that I know for irrational numbers, but these numbers cannot be put in fraction form. I'm just going to say cannot be put in fraction. In this set are special characters like pi, 3.14, and there's a bunch of other numbers. E, and any square root that doesn't have a perfect square. Square root of 2, square root of 3. We would skip 4 because it's a perfect square, and then we would do square root of 5 and so on. Not in that specific order, but any one of the numbers of this form cannot be put in a fraction. Subgroup under rational numbers would be the group of integers. That's the one this problem is referring to. Integers. I think it was a German mathematician that did the study on this group, so that Z kind of represents, I think, a part of his name. Integers are negative and positive whole numbers. So dot, 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 that's that ellipse form I was talking about. And then we do -3, -2, -1, 0, 1, 2, dot, dot, dot. Okay, so all the whole numbers, negative and positive. Under that is a subgroup that we call whole numbers. Whole numbers, this little bold-faced W. Whole numbers start with 0 and just count all the positive whole numbers. 0, 1, 2, 3, dot, 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 and it goes on forever. And then there's one more subgroup in the whole, and that will be natural numbers. Natural numbers are also called counting numbers. When we teach a little kid to count for the first time, we start with the positive number 1, so it just doesn't have a 0. 1, 2, 3, and then dot, dot, dot. Okay, so all of the positive whole numbers. These are the number groupings. So if you see a problem and it refers to a real number or rational number, integer, whole, natural, we can identify where it belongs to. There is a group of natural numbers that you may have used in English. Doesn't have a 0. Roman numerals, if you're familiar. Roman numerals start with I for 1, and it does not contain a 0. Okay, so just some of the Roman numerals. All right, so going over that is going to help you with this problem and future problems. This problem wants us to use set builder form. So let's talk about set builder notation, how to read that. All right, set builder notation starts with a curly bracket and ends with a curly bracket. When we see that curly bracket, this is read the set of all, and then you fill in the blank, whatever you put. So the set of all x values, if I put x here, the set of all natural numbers, I can put any symbol right there. And then let's just say x. So the set of all x values, so I'm going to say x values. Okay, that blank is be something like that. And then there's a vertical bar. That vertical bar is read such that. Okay, so I have this. This is set builder notation. This is a set of all x values such that, and then it's going to give you some condition that meets this. So I'm going to say the set of all x values such that, and I'm going to say x is a natural number. Okay, so this little symbol is an element. That means x is in this group. It's a natural number. And then I'm going to say x is less than 9. Okay, so this is set builder notation. There's different ways that they might write a condition in here, but you will always have an open and closing curly bracket, a variable that describes the numbers that we're going to be inputting, and then a vertical bar that separates the condition. Now, if we were to use the roster method to list this set, roster method, kind of like a class roster, just spells everything out. It lists everything that's in this set. Sometimes we cannot list everything, especially infinite sets, but since this is finite, we can list all these numbers. So natural numbers are counting numbers, 1, 2, 3, and above. We want all the ones that are less than 9. So that would be 1, 2, 3, 4, 5, 6, 7, 8, and then we would stop at 8 because we want all the ones that are less than 9. So using the roster method, this is the same set. One is just listing it, one is a shorthand. All right, now that we know that information, we can answer this question. So it says we're going to use this set builder notation, and it says the set of all x values such that x is an integer and 3 is less than or equal to x, and x is less than or equal to 6. So we want all the numbers between 3 and 6. So roster form, we're going to do curly bracket, and we're going to do 3, 4, 5, 6. Okay, and so that should be our list. All right, then part B has the numbers already in roster form, and it wants us to put it in set builder notation. So we're going to pick which one of these matches this set. So y, the set of all y values such that y is an integer and -4 is less than y and y is less than 1. Now that looks close to correct, but because the inequality symbols do not have an equal to, that little underline, This set would not include 4 and 1, so it would only be 3 and 2. This one, the set of all y values such that y is an integer and y is greater than -5. Greater than -5 actually looks really good because we have -4, -3, -2, -1, and then this dot, dot, dot tells me that it continues. So this set would include all of these numbers and everything greater. This one looks good. The next one says y is an integer and it's greater than or equal to -5. That means we should have a -5 here, and we don't. And this one, y is an integer and -4 is less than or equal to y and less than or equal to 1. So this one does not include the remaining numbers. That little dot, dot, dot says this continues to go. So this is going to be the best answer choice. And it says good.